live. This week we are visited by Rodrigo and Felipe from BlazingSQL. Yeah, you guys want to introduce yourselves quickly?
Felipe, go for it.
Hi, I'm Felipe. I'm the CTO of BlazingSQL, longtime fan of GPUs, Python and Dask now, and Rapids AI.
Can you say all of that with more excitement, Felipe?
Yeah, no, so sorry, I a little bit nervous. I get nervous, but no, this is great. This is great. I will be myself. But yeah, I've been working with the Rapids ecosystem for a long time now. Have been very excited to see how it's grown, how it's changed, how we've made it, distributed now by leveraging Dask, and how it's been really fun to build BlazingSQL, this SQL engine that's built on top of Rapids and Dask. It's just making this has been a lot of fun, if not very, very exhausting. I was up at 2 o'clock this morning is when
I'm sure
my day started.
Cool. So I'm Rodrigo. Felipe is actually my brother as well. So we started this company together. It's a family company. I'm the CEO and one of the co-founders of BlazingSQL. And yeah, we've been looking into GPUs now for about, I want to say it's about 6 years that we've been working with GPUs. We first started playing around with it when we were consultants, and that started leading into us building a company around it. And now we've been building this distributed GPU SQL engine that runs entirely in Python so that people can, accelerate PyData analytics stack with GPU accelerated SQL.
GPU accelerated SQL in Python. That sounds like not what I would have expected to be said five years ago.
Yeah.
GPU accelerated Python.
Neither did we.
Well together.
We had no idea. We were very Python ignoramus when we came into Rapids.
Well, also GPUs in SQL. That is not something that I would have thought about a few years ago as being a natural fit.
So that we've been doing for a long time, actually,
okay.
Before even BlazingSQL. So the first iteration of it was a GPU database, BlazingDB, that was kind of like your more traditional database. You would load up data into it. We had our own GPU accelerated file format called Simpatico, which is fabulous. And I always find a way to bring that into conversations.
Clearly.
Excellent. But yeah, so we had an engine built on GPUs that executed SQL, but it was limited compared to what we have now, mostly because we built everything ourselves. We built our own parser, our own optimizer. We did everything from scratch, and that was a horrible mistake, right? Now we use calcite. Now we use Dask to distribute. Now, we're leveraging, instead of writing all of our own execution kernels, we use cuDF. So it's become more about being smart about how you leverage technologies that are already in existence and then contributing to them when you can, or at least filing issues when you can't. And yeah, that's been a change, kind of.
That's awesome. I love the combination, as you've been saying, of GPUs and SQL, but throwing Dask in the mix, hearing Dask and SQL together is something that really, really excites me.
Yeah, I was really surprised that, that more people weren't on that bandwagon, because it seems it's a very natural kind of introduction to data manipulation, right? It's very easy to write SQL. Right, almost anybody can write SQL, right? And writing Python is wonderful and great, but it's a little bit harder, right? Mm-hmm. So it opens it up to more people, right? And then the amount of Python, you can almost think of the SQL as a good way to introduce people to data manipulation in Python, because they can start doing things in SQL, and then when they want to get clever, right, or do something a little bit fancy, they have to start, leveraging the pandas-like APIs and things like that you guys have so graciously provided,
right?
Or that all the community has.
Hugo, I think you cut out a little bit halfway through your last statement.
Oh yeah,
but at this point, you usually do a little intro. Do you want to intro? Or, yeah.
What I'd love to intro, and my internet connection is slightly unstable this morning.
It's just more exciting.
Maybe Exactly. The suspense is killing me. Yeah, I'd just love people to introduce themselves in the chat. It'd be nice to know who you are, what you do, what your interests are. So that'd be cool. I'm just super excited to have Rodrigo and Felipe on the show today for many reasons, not the least of which is it's Rodrigo's birthday today. So happy birthday, Rodrigo. Thank you so much for joining us. And I'm super happy for Rodrigo, who's experimenting with a lot of different ramen currently. And he's had a few disappointments recently, but he had a fantastic birthday ramen lunch. Isn't that correct?
That's right. I did. I had a good ramen.
Yeah. So I'd love to just say a bit about Coiled, and then I'll get someone to say a bit about Dask. Essentially, what we're doing at Coiled is we're trying to make it really easy for data scientists to scale Python work on clusters. And so we're working on one-click hosted deployments for data scientists and trying to check all the boxes for organizations and institutions, whether it be IT or giving management insight into telemetry to enable more efficient collaboration and these types of things. We're really excited to be opening our beta product soon. So if you're interested, if you're trying to scale Python, it'd be really cool to get you involved in the product development cycle. We'd love your feedback. If you want to come and break our product, we'd really love you to do so. But it's getting harder, which is exciting. I want to hear about Dask for a second, but before that, I've got this beautiful graphic behind me, and I was hoping someone would like to tell us a bit about Rapids Academy.
Yeah, so Rapids Academy it's an initiative from a variety of the Rapids contributors, particularly us, Coiled, or y'all, and Graphistry as well. And basically what we're trying to do is we're trying to create a space where people can come for a variety of webinars, education, even private trainings as well around Rapids and how it is that you can leverage Rapids. And again, it's from a lot of core contributors to the Rapids ecosystems and just talking about this. So we actually have a talk. Well, we had a talk last week where BlazingSQL, we talked specifically about ETL on Rapids and the general kind of ecosystem itself and all of its constituent components. But next week, we have another great talk that's going to be hosted by our partners at Coiled, where y'all will be demonstrating to the world, a lot of multi-GPU usage with Rapids and how it is that you get started with multi-GPU.
I still need to write that talk, but yes, looking forward to that.
Yeah,
I'm excited about that as well. And I've just
do we know the date
in the chat as well.
Okay, great. That's it.
Yep.
There we go.
It's an Eventbrite. Sign up. Matt, as always, I'm sure we'll be engaging.
We hope. We expect.
You see, even with the faces. So I'd love to hear about Dask. I usually ask Matt to tell me about Dask. So maybe I can do that. What's Dask, Matt?
So Hugo always asks me this, and I always defer it to our guests, and we get a variety of different answers. Can we, you guys weren't aware of this, but would one of you like to define Dask?
Felipe, go for it, dude.
Or you could try to do it at the same time. You know that thing where people try to say the same thing?
Finish each other's sandwiches?
Yeah. Oh, man. Now you made me nervous. Put me on the spot. You're like, tell me about my baby. Again, because I worry that I don't use it the right way sometimes, right?
No one gives a good answer. It's okay.
Yeah. I'm going to tell you what Dask has meant to kind of us, right? So if take for granted that people know what a cuDF here is, it's a GPU data frame, right, from the Rapids library. Interacting with a cuDF was, very easy for us at first. Like making bindings to just interact with cuDF was not a complicated thing, but managing the life cycle and existing of that data over time as a user might want it, as a user manipulates it, as a user removes columns as columns and does things in a distributed context was not something that we were hoping to do outside of the very limited scope of executing a query, right? We did not want to be in charge of that. And because of Dask's tight integration with like cuDF for us, right? The fact that you had Dask cuDF that I could instantly take this output that I had on one of my 20 nodes and say, you are part of this group of things and you're all the same and I can do more things to you. Like that was really cool because the more things were, I could do pandas-like operations or I could run another query on it, right? And I could do things like create distributed temporary tables, right? And then have really, really, really fast queries, right? On that in GPU memory data representation, right? So for me, it was like the ability to say like, I can work with this localized data frame. I can even transmit stuff to my other workers and negotiate things like during query execution. But when it goes to the user, when it goes to somebody else, I don't worry about that. I don't worry that it's in the right place, that it's not going out of scope, and that if the user wants to add them all together or run one of like all these like pandas functions, that's going to work, right? With the result that I give them.
So if I were to try to summarize maybe what I think you've heard you say, I think I've heard you say two things. One, for you, Dask is a way to orchestrate lots of Python processes.
Absolutely right.
You don't have to deal with that.
Yeah. And to start the execution of like to actually run the query, right? It's from Dask that, you know, there's basically a function. It's like, hey, generate this graph on all the workers. And then it's prepping the graph, gets that all ready. And then there's, you know, another part where you can like actually execute it, right? And like the fact, like, and Dask lets you kind of like return futures, which is nice because like sometimes you don't want to execute your graph immediately. And like the fact that you had those APIs kind of built into a distributed execution model was huge for us too.
And how did you discover Dask originally?
Through Rapids.
Yeah.
Through Rapids was we discovered Python through Rapids, right? I mean, I knew it existed.
I never heard of it before.
But like, if you told me 3 years ago that I would be writing Python, I'd say I'd rather die. I'd rather die. I'd rather this company be burned down and everyone gets fired before we write a line of Python.
Jesus Christ.
Love it. Hey, we've got a comment in the chat from Josiah Parry. Hey, Josie, who I worked with many years ago. Josie says, my man is hyped on these query speeds, which I really like. We're gonna quote Josie in future on that. Yeah, that's cool. Can you tell us a bit more about Blazing?
Yeah. So, I mean, Felipe, you can go on this, but I can give I'll give a quick opener. So yeah, so
you're a lot faster.
Actually, what I'll do is I'll just share a slide real fast that basically articulates the main message. Can y'all see my slides here?
Yep, you good to go?
Yep.
So Blazing, in the easiest way to think about it, is literally a SQL engine on DataFrames, right? And so we basically took the idea of DataFrames are a really easy way to handle and manipulate a table of data or something that looks similar to a table of data inside memory in Python. And BlazingSQL just basically allows you to run a SQL query on that data frame. So kind of like what Felipe was articulating, right? cuDF is the CUDA data frame library inside Rapids, and it's one of these GPU accelerated data frames, but it looks very similar to Python. So to anyone who knows pandas, or it's very similar to pandas, excuse me, this should look very simple, right? We're just literally reading a CSV into memory. And so this data frame now exists inside GPU memory. And so we can create a table off of that has a name on it. And then we can just run whatever kind of SQL query we want. It's ANSI SQL compliant. It runs entirely within Python. It's a Python package. It's got low-level C and C++ bindings to it, which is why it's so high performant and how it works. But that's really it in a nutshell. BlazingSQL is a SQL engine on data frames. Now, you can extend that out where maybe you're not creating a table off of an in-memory GPU data frame. Maybe you're creating it off of a Dask cuDF, so a distributed, a partitioned cuDF. Maybe you're creating it off of a Pandas data frame or a Dask data frame on Pandas. Maybe you want to be using it off of other in-memory objects like Arrow, or you want to go all the way down to files like Apache Parquet files, Apache Orc files, CSV files, what have you. And maybe those files don't even exist inside the server that you're running or the computer that you're running. Maybe they exist in the data lake, right? So it's how is it that we can create this SQL engine that just runs directly off of files and in-memory data frame representations and have really high performant, really awesome query execution that works really effectively in Python. And what's great, right, is like this returns either a cuDF or a Dask cuDF. And so just by running this particular statement right here, we actually have one of these data frames that then we can then hand off to more ETL data-like transformations, or we can hand it off to other technologies that know how to use a cuDF. So maybe that's data shader and doing visualization. Maybe that's cuML, which is basically like scikit-learn, but also GPU accelerated and built around cuDF. Deep learning frameworks, all sorts of things that are integrated with the Rapids ecosystem. And so that's the main idea. It's just SQL on data frames, right? And what does that enable you to do when you're starting to think in that kind of mindset?
Yeah, that's super exciting. Sorry to interrupt. So one of the common requests we get for Dask is, hey, do you support SQL? Like, I love that I can read in some data from, my S3 buckets somewhere. I can do some custom Python manipulation, but then I want to hand that off to SQL engine and, send that to Tableau or something. And our answer has always been like, no, there's no good SQL system in Python. And now there is, if you have GPUs. Right? So this is great. This great capability. And the fact that we can sort of swap in and out, sort of really emphasizes that composability of the PyData ecosystem. We use some tools when they're good, and then we can interoperate with others. There's a question from Josiah and Martin a little bit on query plan optimization. So you guys are obviously very, very fast when we're running some kernel of a query. Does Blazing also do high-level query optimization?
Yes, so we leverage Apache Calcite for that. Apache Calcite is what optimizes our relational algebra. So it optimizes the logical plan. The physical plan is optimized when the graph is generated and also during execution, depending on like how much data it estimates. Like if you're doing a join, it'll optimize, which table it scatters based on estimates after it's processed a little bit. But all of the logical planning and that optimization happens in Calcite, Apache Calcite.
Calcite's like the common system. Like a lot of other systems also use Calcite. Is that right?
Oh yeah, I mean, like
Hive uses it, OmniSci uses it. There's a ton. I'd have to pull it up to even know everyone, but
and it's a Java basically project, and we use it from Python, right, with JPython, which like at first it felt a little dirty, but you know what? It works. It plans the relational algebra quickly, and it's a very it's a very easy API. It takes SQL and it spits out a plan, and that's the only thing it has to do.
Great.
Yeah. Also, something that Felipe didn't mention in terms of other optimizations that SQL enables us to do is predicate pushdown. So if we're talking about a bunch of Apache Parquet files, Apache Orc files, or even Hive, actually, I forgot to mention, you can even create tables off of Hive cursors in databases. That metadata.
Yeah, go ahead.
Yeah, that metadata enables us to cull partitions of data that have no reason even being brought in. So it saves us a lot on I/O, network, and also optimizes plans pretty heavily.
Great. So I'd love to jump into an example. You mentioned that you can push stuff to all types of systems, including data shader. And I think maybe you have an example where we can do that. While you're pulling that up, it'd be great to know a bit about, I suppose, specific applications or what type of industries maybe would leverage is the best, or when people would want to move to use something like Blazing.
Yeah, so our first of all, we have customers in a bunch of different places. Retail, finance, there's a lot of different workloads where people are leveraging us. A really good one is also in supercomputing. So we actually started getting running off of the Summit supercomputer recently. A researcher has gotten us running there, and so they're accelerating a lot of metadata research. So if you've got like a ton of metadata that's in the terabytes, and what is it that you're going to do with that? Sometimes you literally just want to look at it, explore it. And so interactive 3-second, 5-second queries over terabytes of data is pretty compelling for a lot of researchers that are just trying to engage in exploratory workflows. But then there's also basically what happens if you can take a PyData like workload that a data scientist whips up and then have it scale up, not just to a few gigabytes, but to a few terabytes worth of data so that it can actually be put into production. So that's what like our retail user, our retail customer specifically is looking at us for. How is it that I can put the ownership of the production pipelines on the data scientist, as opposed to having the data scientist hand it over to a data engineering team that then has to go and repurpose it in something like Apache Spark. And that ownership between the data scientist and the production pipeline is entirely lost, right? And so what if you can just interactively be working off of those, large scale data sets, and then that creates performant code that can then get deployed into production. And so that's where our engine really starts making a lot of sense.
That's great. And that's actually a trend we're seeing through these conversations as well. Last week, we had Alex Egg from Grubhub on, who productionizes his model in the end using TensorFlow in order to make it as seamless organizationally. So he isn't like serving models to another team that then needs to figure that.
Yep. Oh, I think we lost him. Yeah. So real fast, just to let everyone know, one of the problems that we see a lot of the time when it comes to GPU and getting started with GPUs for the first time is gaining access to an actual GPU, right? So a lot of people might not necessarily have one inside of their laptops. They might not necessarily know how to spin one up in the cloud. And so we have a really simple free environment that's actually built on top of Jupyter Hub and Jupyter Lab that people can use. And it's at app.blazingsql.com. So feel free to use it, and you can follow along basically anything I'm going to show right now. But what I'm going to do is I'm going to show basically a Blazing SQL query and how you can pipe it into Datashader or a data visualization tool. So if you're familiar with PySpark, or you do anything necessarily with PySpark, this context is probably pretty familiar to you. And Blazing SQL, like we said, it's not a data warehouse. It's not a DBMS. It's not like it knows things whenever you install it and start it up. It's pretty naive. And so what happens is we have to create this context. And this context is going to maintain an awareness of what tables are called, where they're located, storage plugins or systems that we might be connecting to. And so all I have to do is, this is one of the introductory notebooks, by the way, that are available whenever you come in. All I have to do is just execute this, and I can get this Blazing context. And then if I go down, I think I have an example I want to show down here. I just want to make sure I have the right data set. The data set is taxi. So I'm going to pull that in. So here, this is a quick example of how it is that you can register a storage plugin. I'll actually zoom in because I probably have this pretty small for most people. And what I do here is this Blazing context that I created, I can effectively just register an S3 bucket. So this is a totally public S3 bucket. And what I'm going to do on that S3 bucket is I'm going to create a Blazing SQL table that references a file inside that S3 bucket. So I register this, then I can actually do file paths that point directly to it. In the case that I have a lot of stuff in this directory, so I'm not going to do it. But if it was something like this, if I did something like this, and it was literally just a bunch of Apache Parquet files that were yellow taxi files, this would also create a table off of, a list of files effectively. So what I do is I can just create a table, and you can see on my right, I actually have my GPU resources kind of showing what's going on, and you just see a quick little spike. That just literally means it read in the metadata real fast, and it now understands the schema, and it understands, the row groups and what it is associated with it. And so kind of like what I was saying before, I'll just show this off real fast before we go to the actual visualization, is this query right here. If I just do bc.sql, this right here gives me a cuDF data frame. And so once I have that cuDF data frame, I can start running pandas like utilities or functions, methods on top of that data frame. And so it really easily gets you into the experience of running SQL inside Python, but then getting all of the data frame kind of functionality that you're looking for. So down here, what I'm going to do is
I'm literally a bit more about cuDF data frames.
I can explain it a lot better. You know what? I've got a slide about that. Awesome. So if you're thinking about the Rapids ecosystem is a whole slew of technologies. This is now out of date. There's actually even more packages here that are integrally part of the Rapids ecosystem, because the whole space is just growing so fast. But cuDF is effectively the data frame library. And the easiest way to think about cuDF is it's pandas on GPUs, right? That's the soundbite. It's pandas on GPUs. So awesome. You basically get all the functionality you get out of pandas. It mirrors the API as closely as possible. It's getting better. If it messes up on something, please file an issue for it, because that's how we can deal with it. But it mirrors the Pandas API, and the only difference is it's just wildly faster. So it actually does reading of files faster. So its IO libraries are incredibly fast. It runs a ton of different, operations from merges, sorts, group bys, etc., wildly quickly. And all of the low-level primitives inside cuDF are the same exact primitives that BlazingSQL is operating on top of. And that's how we've created this holistic ecosystem where, dozens and dozens of engineers are writing to this libcuDF, this C++ library that backs up the cuDF and BlazingSQL, but it really just makes all of us faster, So if someone decides to make a group by faster inside libcuDF, all of a sudden BlazingSQL group bys are faster, which if you're in SQL and you get fast, that's a big deal. Just constantly accelerating SQL queries. And so that's what cuDF is. Do you think that
that's
explains?
Awesome. Yeah.
Yeah.
I don't know if Felipe wants to add anything, but.
So just to kind of show off real fast, right, how all of this works together. So a lot of things can now take cuDF and Dask cuDF. In this particular example, we're doing just a straight cuDF, but you can see that we're running basically a query. It's a super simple query. And this is New York City taxi data. So it's basically pick up and drop off coordinates of taxi rides in New York. This is a super popular data set if you're not familiar with it. There's a ton, there's like 500 gigs of CSV files that people can play around with this taxi data set. But here we basically just pulling out a couple of columns and we're running a where clause on a cast of a timestamp. And you can see right here, we literally just write, this bc.sql, and this returns a cuDF. And because Datashader knows how to take a cuDF, for anyone who's not familiar with Datashader, it's a really great Anaconda project. It enables you to do all sorts of visualization off of DataFrames and Dask DataFrames. And so we can pass this in and literally it'll just render the results of our query.
Wait, how long did that take?
Oh, I don't know. Let's try it out. Let's see.
Let's see. Let's do it.
Yeah.
All right, 488 milliseconds, 486 milliseconds. Let's see how big this is real fast. Just select.
Is that data already in RAM, or are you also including the time to read it in?
So in this one, this is in, I think this is on S3. This is an S3 data set. So it's not too big. It's an Apache Parquet. It's 1 million rows. It's 1 million rows in Apache Parquet that lives on S3. But this query is not bringing it from in-memory. This is bringing it from S3.
No, that makes sense. Okay, great.
Yeah.
Cool. So we've just got a few questions in the chat. Alex Egg, who was our guest last week from Grubhub, asks, can this work on the older EC2 P2 GPUs?
It can work on, the P2s, yes. It can definitely work on P2s. It needs Pascal Architecture Plus. So it won't work on a K80 or an M40, for example. But okay. P2s, it works straight on. Here, we're using Tesla T4s, by the way, which are a great deal on AWS.
Awesome. Martin Frederick has a question. Can we scale our query across multiple GPUs?
Yes, you can.
Multiple nodes. Yes. So like on Summit, for example, is running 167, GPUs. We've run tests ourselves with NVIDIA, I think 17 times 16, whatever that number is.
17 times 8.
Oh, that's it. Yeah. Oh yeah, it's 8 per. Yeah. There you go. So yeah, 136. But yeah, no, you can. It definitely scales to multiple nodes, multiple GPUs. That is quintessential here. I
can show a quick example of what that even looks like as well.
Right.
So
while you're doing that, we've just got one more question that Josiah asks. He's not sure he understands where BlazingSQL would be preferable to pure cuDF, particularly since the query returns a cuDF.
Yeah, so I'll go for it, Felipe.
All right, so there's a couple of things. One, because of the way that the SQL is orchestrated, and we are actually built on top of libcuDF, the C++ library, right? And Blazing does a couple of things for you. One, it's all in C++ once you get down to query execution. Two, I don't know, it's a lot easier to optimize SQL than it is to optimize Python code, right? You can write pretty dumb SQL and actually get pretty optimal relational algebra out of it. And the other thing is that Blazing handles out of core. So as your query is executing, during query execution, those data frames can live in the GPU, on disk, in RAM, and it basically between every single transformation in the query graph, there is a cache where that data can be stored temporarily. So it gives you a degree of scale that is a little bit harder to achieve with cuDF, which right now is a GPU in-memory representation only. And at least for me, it's a lot easier for us to optimize SQL than it is to optimize someone's code.
Yeah, to kind of pull on that thread too, right? It's also about taste and preferences, you know? So if you personally prefer pandas and pandas data frame manipulations, like that makes total sense. And there's a ton of people that do that. Sometimes people don't necessarily prefer that. A lot of people know SQL, and this is a really easy on-ramp for those people to really start getting proficient and powerful inside Python, right?
And
which is something that we really care about.
Get in there.
Are you saying that the Pandas API is not universally loved and no?
No, hell no. No, you can use both. Like that's the whole point.
I was totally trolling you. Sorry.
Yeah.
Were you though?
Is that sometimes you want to use SQL, and sometimes because that is a more elegant way of expressing what you want to do, and sometimes it's more elegant to express that thought in pandas.
I'm totally joking around. Like anybody who's replicated the Pandas API, like a different DataFrame, knows it is it's a very pragmatic but sort of warty API.
Yeah, pros and cons to everything. And so yeah, we just think about how is it that, because like our whole vision, right, is so this is empowering for data scientists, but there's an entire community of data analysts out there that one are either becoming programmatically proficient or need to become programmatically proficient for their long-term career trajectory, right? And for us, SQL is a really great on-ramp in enabling these individuals who have these capabilities to start coming in here and becoming dangerous and powerful relatively quickly, as opposed to, you know, having to start figuring out an entirely new paradigm of data manipulation. That is, sorry.
No, go ahead. You're on a roll.
That can be pretty vexing or confusing to people if you've never seen it before.
So I really liked, it was cool seeing SQL in a Jupyter Notebook. You had like Jupyter Lab running. I also love the dashboard you had on the right side. I think my team helped build that dashboard.
The MD dashboard.
Yeah.
Yeah.
It's also a Bokeh app. We highly recommend Bokeh. But yeah, so it's interesting seeing SQL in a Jupyter Notebook. I imagine lots of your analysts don't necessarily want to use a Jupyter Notebook though. They want to use Tableau or some other BI, business intelligence tooling. Can I hook Blazing up to one of these point and click GUI applications, or is that still future work?
That's definitely future work. So there's different ways that people have kind of enabled that. So we have some users that have actually tried to enable that internally for their customers or for themselves.
Enable that.
But yeah, there's not a ton of different ways to necessarily do it. We're really focused on the Pythonic experience right now and trying to just hone in on that and let people in Jupyter be really powerful and comfortable. And then from there, we want to start taking new endpoints that enable you to plug it into Tableau or Looker or whatever it is that you happen to, whatever is your poison when it comes to data viz.
So maybe we can jump back into the example or move on to the next one, because Felipe mentioned out of core stuff.
So real fast, what I'll just show is this is literally what it takes. This is the most basic implementation of how you can get Blazing SQL in a distributed or a multi-GPU context, which is the most important thing here is really down here. Whenever you instantiate your Blazing context, if you pass it a Dask client, if that Dask client is aware of GPU workers across a cluster, then Dask will actually be what launches the Blazing SQL workers across that entire cluster. And so this is just a super basic example using local CUDA cluster, which basically just finds all the GPUs on a server. In this case, it's one, but if there were, 4 here, it would have found 4 workers that we could have been utilizing. And that's all it takes. Once you run this, once you create a Blazing context that has a Dask client passed in as one of the arguments, that is a multi-GPU, multi-node potentially Dask cluster that you can start interacting with.
So it looks like, for example, if I had a Kubernetes cluster with GPUs on it, if you wanted to deploy Blazing onto that cluster, you would use the Dask Kubernetes project or something like that?
That's exactly right. So that's how you would have it. That's how you would have it deployed, and you would have to have BlazingSQL installed in those pods as well, or those containers. But if you literally just get, a Dask scheduler out of that Kubernetes cluster that you're talking about, and know how to point it to it, like you're done. Like BlazingSQL will now be running. So it's really pick your poison with Dask, and then pass that to BlazingSQL so that BlazingSQL just knows where everyone is.
You will never know the pain of interacting with every single possible cluster management system.
Oh, we do. That's why we didn't do it. We do know that pain, and like getting a multi-GPU Blazing DB cluster. So before BlazingSQL and we went open source with the Rapids stack, we were building an old school DBMS that was called BlazingDB. And the deployment scripts of that, I remember there was one time where Felipe said, you will never, I said, hey, for this to be effective, I need to be able to deploy a BlazingDB cluster on my own relatively easily. And his response to that was, you will never be able to deploy it. This is for only the hardcore of the hardcore. And
if you're not an Uber, you're definitely not wanting to do this.
Yeah, and
very fragile.
We had a long talk about that and thought maybe this product isn't really what we wanted to make. So yeah, that's why we rely on y'all and other Dask contributors to solve that problem for us.
Happy to support.
Yeah, we appreciate it. So real fast, just some of the things that I like to show off. We've got this welcome notebook. I actually kind of showed off the S3 work. So,
and can we share these notebooks after?
Yeah. So
if you log in to app.BlazingSQL, you have all these notebooks.
Yeah. So
app.BlazingSQL.
app.BlazingSQL.com.
So you have access to all these notebooks. It's also on GitHub. It's called our welcome to BlazingSQL notebooks, but you can run this on any environment that has, BlazingSQL and cuDF and cuML and all the dependencies installed. But if you don't want to go through the trouble of, installing CUDA drivers and getting all these dependencies installed via Conda, you can just go straight to the app. And these are automatically downloaded for you whenever you first log in. So real fast, just jumping through the welcome notebook, it's really all about what we were discussing before, right? About there is this GPU data frame. The GPU data frame can either be manipulated through SQL, or it can be manipulated through pandas. So kind of what I was describing before, right? We create this Blazing context. We can create a table off of a CSV file, and then we can just query it and start looking at it. If we want to make it a little bit smaller, just to see, the top 10 rows or 5 rows, we can just do .head. And like we were mentioning before, all of these return a cuDF data frame. So very similarly, back into cuDF, if you're familiar with pandas, a lot of this work should look really similar to you, right? It's just this CUDA data frame. And we can either make it off of BlazingSQL queries, like we were showing here, or we can read in files ourselves with cuDF.read.csv. But we get all the kind of, bells and whistles that come with pandas, except everything's happening on the GPU. So this is just shy of, I think, like 1 million rows. And just, quick filters in 12 milliseconds to put things into context, right? It's all really quite fast. We'll do time it just to see how well it runs when it's going through quite a bit. And you can see again, right? This is the NB dashboard we were talking about, where it's actually showing off all that different, everything that's happening on the GPU as we're going through it. So you can see, yeah, it's basically 11.4 milliseconds, even when it tried it a bunch of times. Where things start getting really interesting is because it's built on these standards, cuDF is built on these, open source standards. We can very easily pass things from cuDF to pandas because it's all built on top of Apache Arrow. So as I was mentioning before, right, if this here is a cuDF, then I can just take that cuDF and I can run 2 pandas. And now basically what I have here is a pandas data frame that I have highlighted here. So if I have a pandas data frame, now I can do anything I want with pandas as well. So maybe I want to rely on BlazingSQL and cuDF to do the heavy lifting of the ETL and the data manipulation, but I want to be able to plug into something that understands pandas and might not necessarily understand cuDF. And so if I want to plot it, for example, with matplotlib, I can just literally just do .plot as if it's a pandas data frame because it literally is one. And now I'm running visualizations leveraging BlazingSQL. And so I'm running SQL queries to get my viz. And so if I don't know pandas, right, all of a sudden Python and viz is opening up to me, but I do know SQL, Python and data visualization is opening up to me. Similarly, this is the data shader example we showed just a second ago, where we're just rendering a bunch of different points. But where it also gets interesting is, the other packages inside Rapids. So I was mentioning before, here, I'll just open this up real fast. So all the data prep, data manipulation is on the left-hand side of this chart. It's BlazingSQL and it's cuDF. And we leverage Dask for, taking things to multi-GPU, multi-node. But then when we start thinking about the other components of the data pipeline, there's machine learning. So cuML it's basically scikit-learn on GPUs. And it's also wildly performant, and it interoperates with the same, data frame that we have in memory. There's also cuGraph. There's connectivity to deep learning frameworks and visualization, like we were showing. So here in cuML, this is a straight up pretty basic, just linear regression example, but we can bring in this, we can bring in these cuML packages, and we can just start prepping data. So here you have an example of us getting, a bunch of columns of data for our training data and our test data. And here you have a nice example where you're actually using SQL with pandas kind of API to get out the column that you want, right? And so this is just like a very simple, but useful example to see what all of this looks like. And literally that's all it takes, because cuDF or cuML also has the train test split. We literally create all of our training and test data this way, and I can just pass it. These are all cuDFs, and I pass it, and I'm able to run this linear regression off of this test data set really, really quickly. And so
that's great. And if the API looks exactly like scikit-learn, right? Is it running scikit-learn in the back end?
No. I mean, it's re-implementation of scikit-learn on cuML.
Okay.
I don't know exactly what happens under the hood. There's a whole team of people that are working on that part, and we're ETL folk. But yeah, that's exactly the idea. You should just think of this like pandas and scikit-learn. Now there's SQL functionality added to this. And the main thing is that it'll run wildly fast, right? Wildly fast. What
an exciting ecosystem.
Mm-hmm. Yeah.
I really do like mixing programming and SQL. Like going from being a SQL engine, making JDBC drivers, and then thinking like, oh, if somebody wants to interact with this, they have to consume it somehow. Like there was the connector everyone used, and then there was like the fast binary style connector that nobody in their right mind could actually write an adapter for, except for us to give everyone the simpler one. And it sucked. You couldn't do anything with it. Like you could just run a query and get the result. But like now, like I wanted to make like a trading simulation to prove my friend wrong, right? And I was able to do that by like mixing, like SQL and pandas and like and Dask to be able to run it fast enough. Like that kind of stuff is just so different from like your traditional kind of, I can either write SQL or I can, like write code.
Yeah. The thread Philippe is pulling on is super interesting, right? Because you can think about like procedural. So normally what would happen is you'd write SQL statements, and then your SQL would start getting wildly complicated as you're trying to get it to do more and more thing inside of your SQL statement. And so it'll get more and more nested typically, and we'll get, multi-page wild SQL, statements from customers that are just insane. And what people like, one of the things I always really wanted to do when I was working in a lot more SQL as an analyst was, how can I make this a little bit more procedural, right? So there's procedural SQL, and that lets you start doing things. But this kind of takes it to a whole nother level because it's the shared memory object in Python that you can basically bring anything from the Python ecosystem now to really start doing things with that data frame. And so that's why SQL on data frames is so powerful. Because like, if I want to do something, like new table, and I want to literally just do bc.sql select star from taxi limit 1000, that'll work, right? Like there is no DDL SQL. There is no data definition language SQL for BlazingSQL. It happens entirely inside Python. And so if I take that,
that returns a Dask data frame too, right?
Mm-hmm.
Like
so if I do that, and then just do this from new table, like that's the beauty of this whole thing, right? Like I can chain this together and I can get all sorts of really interesting workflows. I can maybe there's some reason that I need this to be in like a for loop, right? For whatever, yada, 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 and going over it. So that's kind of the power of like having this SQL that is on data frames, because I can start creating these procedural workflows that can represent full data pipelines. And I'm not just in a query editor where it's like, oh, I've got these 30 queries that if I could run these in succession, it'll work, with a bunch of create table statements inside of them to like stage views and all that stuff. I can literally just put it in a Pythonic style pipeline and we're done.
Historically, there's some value of Python as being like the glue language between all of these like C++ or Fortran codes, right? You would like run this Fortran code, then you get this object back. You run this other Fortran code. And that seems like you sort of replaced that Fortran with SQL, right? We can now like use Python as this glue between lots of different kinds of SQL queries. And that's really powerful.
Yep, that's exactly right.
So I've been quiet for the last 5 minutes because I've been playing around with app.blazingsql.com. So I in Matt's first.
There he goes.
I've never played with Blazing before, but it was fun. I ran a couple of issues. First, I ran into like a 500 error when I signed in the first time.
Yeah, we're looking for that. We're gonna find it. we're looking for it. Yeah, refresh. If you got it, refresh.
Sometimes you have to clear your cookie or open it up.
I did then refresh. I got a 400 error, and then I refreshed again, and I got in. It was great.
You see, it works.
Yeah, it worked. So I thought I'd play a little bit. Like this is again just me screwing around. So you guys do have like with these really fancy demos. I'm just gonna do a little simple thing. We have this Dask. So inside the Dask library, there's a datasets module, which includes like some fake datasets like this one. So great.
I didn't even know that.
Yeah, that's
great.
Amazing for demonstrations too. So I probably want to make this like a cuDF data frame. Or could I hand BlazingSQL just a Dask data frame with pandas? Or does it want a cuDF data frame?
No, you're going to hand it.
Oh, you can? Can you?
Wait, you should be able to. This is you, man. You're the CTO, dude.
I don't think you can.
Oh, you're supposed to be able to. All right, we'll talk about that.
Dude,
let's
let's
try
try
my Dask data frame of pandas data frames to Dask data frame cuDF data frames by just mapping the cuDF from pandas function on every piece, right? If I wanted to, maybe I'll persist that in RAM. Oh wait, import cuDF. There we go. Yeah, so I could do cuDF things here, like get the first few elements, or I could do blazing context dot create table. I think I did this just a moment ago. Oh wait, no, I need to run all this stuff. Yes, this is fun. I'm making a Dask cluster, wrapping the cluster in a Dask client. Giving that Dask client the blazing context. I got a little bit tripped up specifying a network interface. I hope local was fine.
So that has to do with things like UCX and us not quite figuring out how to find that yet. We're working on you not having to do that, but what's going on with cuDF?
Yeah.
Okay.
Anyway, got that running. I was calling cuDF from cuDF on a cuDF data frame. So I want to create a table. Let's call it maybe foo. I'll give it my Dask data frame. That works out okay. Then bc.sql I might do the same thing I did before. So select star from foo, limit 5. And that I think should give me the same thing as cell 11. Boop. Great, give me a Dask data frame. So maybe I call .compute on that.
Mm-hmm. That's all it is.
Although, wait a minute. The entries are different.
The order is not deterministic. You have to order by something if you want it to be
Right.
deterministic.
Right, so SQL, right. So because this is SQL, we actually lost a couple of things, it looks like. We lost ordering. We also lost the pandas index. It seems like we lost the timestamp column.
Yes, so right now in cuDF, it's going like the way that we interact with cuDF, it's assuming that the columns are columns, I guess. Maybe we have to look into persisting indexes when they're not that trivial, like 0 to N1. That's a good learning.
You need that before your limit.
Yeah.
So I think, oh, yeah.
Anyway, I just did this. It was a lot of fun. Anybody can do this, presumably, who's logged in right now. Maybe we can crash your systems pretty quickly. I'll stop sharing and let you guys get back to the fun.
Yeah,
think
so
you actually
no,
need to
that
be-
was a lot of fun. Sorry, go on, Felipe. That was amazing seeing Matt just dive in there and have debugging help from the legendary brothers.
It's a word, reserved word.
Reserved word.
Reserved word, dude. I know. I was looking at it too.
Someone, look, sorry for clicking.
So I need to rename
What
timestamp
happened?
to like other timestamp.
Yeah, that'll work. That'll get you.
No, let's just take. Yeah, that should work.
All right. So
So
every
we've
time I
got
do
about
this-
eight minutes left. What do you want to do with that time? Do you want to show us another short
cuDF
example
doesn't
how
let
to
you
pull
rename the
stuff,
index.
or
Are there any other questions, or is there any other threads we want to pull on?
I think we're good for questions from the crowd. But if people have questions
Yeah.
now, please shoot through. But otherwise, however you'd like to wrap up, whether you've got a short example or
Yeah, I've got some information that'll probably just be enticing to people that are thinking about this at large scale. So one of the things that we've been working on, and we're going to be releasing a lot of information on this, is basically big data benchmark. So we're trying to show to the world, right, what can be accomplished with this particular stack. And what we did is there's this one particular benchmark. If you're not familiar with TPC organization, they're really well known in the database space, particularly. But as you know, the database space has been evolving, and they're not just DBMSs anymore. They're also SQL engines and all these distributed compute frameworks that are coming out, like Spark, Spark, Hadoop, et cetera. And Dask, excuse me, us, all of us doing what we're doing.
Save the best till last.
Yeah. We basically put together this workload. So this is run with BlazingSQL, Dask, Rapids, etc. And this big data benchmark, what it does is it's got like 30 different workloads, and those 30 different workflows will do things from ETL stages of raw data in some sort of storage layer, all the way through machine learning, NLP, all sorts of different types of workflows. And so what we did here is showing off some early results that we started getting out of this, where the current contender for the 1 terabyte benchmark is actually a Huawei cluster. And for about half the price of that particular cluster, we, on average, were getting 44 times faster workflow performance, right? So this is the end-to-end workflow from like the raw data to the machine learning completed and the results pushed out there. And so
that's why it's kind of small. You should mention that's a log scale.
Yeah, so I'm gonna thank you. Yeah, so this is a log scale.
We're brothers.
Yeah, that's right. We're just two brothers. And so
with a log scale.
Yeah. So if you look at this, like I just picked five random workflows. I picked the 2 best, the 2 worst, and then one that was down the middle to kind of show what it looks like. But if you look on the right-hand side here, these are like 200 times faster workflows. Like we're talking about things that took, thousands of seconds that are taking few seconds, under 10 seconds or almost 1,000 seconds, excuse me, to, just a few seconds. And so that's really what this stack is about. It's about, because it's open source, because of how it's put together, you're able to create these holistic pipelines, even though, you know, like BlazingSQL and Rapids ecosystem are all pretty early stage projects. Dask is the most mature project of all of us, really. Yeah, that's right.
Granddaddy.
So like, so even with like these early stage versions of these projects, we're getting wildly incredible results. And to put things into context, like 44x is bananas for these benchmarks. Like what these things like will normally see, like an improvement of 1.2x, you know, is considered like reason for quite a bit of celebration, right? And so the fact that we're getting such ridiculous performance results is really indicative of like the paradigm shift that building out for GPUs, for advanced networking, for advanced storage, right? Like building an architecture that understands these things and how to leverage all of this heterogeneous compute infrastructure is really what enables us to demonstrate these kind of results.
That's
So
amazing.
Matt, it seemed like you wanted to say, okay, sorry. Yeah, there you go.
No, I just want to say that's amazing. So like, it's not that just like Rapids is faster than the Huawei system. Like there are presumably dozens of applicants to this benchmark.
Mm-hmm.
Is that right? And so
Oh yeah. So like
and,
Dask is essential there, right? It's actually the thing that's distributing everything.
so what I'm saying, like there's a bunch of submissions to this benchmark. This isn't just like you beat one other system. This is you beat everybody else who submitted to this benchmark, which is, you know, probably Dell did some Spark workload and HP did some like combination Spark plus MapReduce workload. I guess the best thing that came out was Cloudera with Huawei on Cloudera with Hadoop.
Yeah.
And everyone is down there sort of competing for something, and then you guys just sort of walked in and swept with a 44x displacement.
Nobody had ever heard of us. Who are those Latinos coming in with this hot stuff? No, but there was a ton of people, right? Like
and
we all
say it was a sweeping kind of motion. It was more like a shoveling through like the jungle kind of thing, you know. There was a lot of work.
Yeah, and there's a lot of people. So a ton of people at NVIDIA worked on this. Matt, you know a lot of people that worked on this. And there's a lot of projects that are also that made this a reality. Blazing was not the only thing here by a long shot. This was a huge concerted effort of a ton of different groups that led us to have these kind of results.
Hooray, community.
Hooray, community indeed.
Exactly. So it's time to wrap up. I'd love anyone who joined or who's watching to jump in like Matt just did to a notebook and see how quick you can accelerate your data work with Blazing and get in touch with us to let us know how you go. Also check out coiled.io and get involved in our.
Hugo just dropped off. He's in an awkward internet situation. Log into coiled.io and check out our sign up for our beta. We'll be having more announcements, I think, sometime next week or the following week. Yeah, Hugo, you're back. Want to continue?
Oh yeah, I'm sorry about that. Yeah, I was saying, get involved, check out Blazing, get up and running with it. Check out sign up for our beta product if you'd like. On top of that, we put a link down for Matt's multi-GPU webinar next week. Is there any other way that you'd like people to get involved?
Yeah. So check out Rapids Academy as we were talking. There's a talk next week, 11 a.m. Pacific on August 11th, where Matt's going to be talking about multi-GPU with the ecosystem. And also BlazingSQL. It's an open source project. Issues. If you have any problems, anything doesn't necessarily work out the way you want it to, we're always looking for more and more community support and figuring out what works and what doesn't. Kind of to Matt's point earlier, it's pretty easy to break. It's getting harder to break it over time, but still pretty easy to break. So help us out.
It was really easy to jump in. Like I felt really comfortable playing with it for a few minutes, comfortable enough to make a fool out of myself on live TV.
Yeah, that's right. You came out good though. So check it out. Also app.blazingsql.com. It's got the entire Rapids ecosystem pre-installed, including Dask as well. So you can get playing around with what's going on there. And it's probably just the easiest and fastest way to get started. Literally in a matter of 10 seconds, you can be writing your first GPU code. And so don't be scared of GPUs. They can be scary at times, but they don't have to be, and we did everything we can to make it so they aren't.
We're going to close out now, but thank you everyone for joining, and thank you Rodrigo and Felipe for such a wonderful session, and happy birthday once again.
Thank you very much for having us.
Great pleasure.
We finished each other's sentences.
Sometimes.
Please.